And we're going to take a look at solving radical equations. This will be pretty quick because it's a relatively straightforward process. So there's really three things you want to do. The first thing when you're solving a radical equation is you want to isolate the radical expression. That means that on one side of the equal sign, all you want is the radical. So for example, in this example, I have a plus 3 in addition to the square root of x. So to get rid of the 3, I'll subtract it, and I get it to this point. Now I have it isolated. Step 2, you want to eliminate the radical. Okay, well, how do you eliminate a radical? You raise it to the power of the index. So for example, if you square a square root, what comes out of it? It comes whatever is under the radical. So for example, square root of 5 squared is equal to 5. So the square root and the square cancel each other out, leaving you just the radicand underneath. Cube root, you would go ahead and cube both sides, and that would eliminate the cube root. Okay. So in this example, we had the square root was equal to 2. If I square both sides, square root of x squared is x, 2 squared is 4. There's my solution. Nothing really to solve in this one. Now, when you check for extraneous solutions, okay, what you have to do is you have to substitute your solution back into the original equation to verify it works. The primary extraneous solution you're going to get is when you have the square root of x equal to a negative number. Okay, that's a non-real answer. We haven't gotten into imaginary numbers yet. So the answer is does not exist or is no real solution. Okay. Okay, so I'm just going to scroll down here and just look at a couple examples. This first example here, I'll just do it's real simple. If the radical is isolated already, so if I square both sides, then what do I get? I get x minus 4 is equal to 4. Add 4 to both sides, I get x is equal to 8. Let me check the solution. Well, 8 minus 4 is 4. Square root of 4 is 2. It is equal to a positive number, so I'm good to go. Let's look at one minorly more complicated. Well, I want to isolate this radical right here. That means I got to get rid of the minus 6, so I add 6. And then we do just like we did above, square both sides, results in this. And then add 11 to both sides, I get 60. Let me plug it in. 60 minus 11 is 49. 49 square root of 49 is 7. 7 minus 6 is 1. So the answer does check. Okay, these next two problems I'm not going to do. They're not any more difficult. This one, I'll do this one real quick. So we want to isolate the radical. I would get rid of the negative 5 first by adding 5. Okay, that gives me the 8 square root of x minus 4 is equal to 32. I got to get rid of the 8, so I divide both sides by 8. That gives me the square root of x minus 4 is equal to a 4. Square both sides to get rid of the square root. I get 16, which means x is going to be equal to a 20. And if I check it, it's going to be fine. You can see this is not easy. And so you just got to be careful. We haven't had any that don't work yet, but this would be a problem right here that you would have to answer the does not exist because you're taking the square root of something and we're looking for the primary or the positive root. I know that the square root is a plus minus, but in this case, we are only looking at primary or positive roots. So anytime you have a square root equal to a negative number, we're just going to say it does not exist or it's no real solution. So here, let's look at a couple. So I'm just you can see the work. I had to add z to isolate the radical. So on the right, it gives me z minus 10. And then when I square both sides, I just get the radicand here is z plus 100, and then I have z minus 10 squared. Remember, z minus 10 squared is z minus 10 times z minus 10, and if you multiply that all out, you get this, okay, z squared minus 20z plus 100. So I've replaced that with z squared minus 20z plus 100. I'll go ahead and subtract the z and subtract 100 because this is quadratic. And quadratic equations, I've got to use factoring. I got to get everything to one side, set it equal to 0. So if I factor out a z, okay, then I'll have z times z minus 21, which means the two solutions is z is equal to 0 or z is equal to a 21. Now, if I check 0 into the equation, um, then it will not check because I'm going to get 10 minus 0 is equal to a minus 10. I cannot, so 10 does not equal a negative 10. And again, I've got this negative sign uh, in the right hand of the original equation. Even with that negative z in there, I do have to check it. So that doesn't check because it does not equal a negative 10. However, 21, if I substitute it in, 21 plus 10 is 121. The square root of that is 11. 11 minus 21 does equal a negative 10. So this answer is okay. The fact that I have a negative number here in this case doesn't necessarily immediately eliminate it because I do have this minus z that's not under the square root. So this requires me to actually check it to make sure. So one solution is no good, the other solution is fine. Okay. This next problem, I'll just I'll just talk through this one real quick because it's basically the same thing. I'll add 2 to get rid of the negative 2 here. Then I square both sides. I get the radicand on the left. When I square x plus 2 squared, I get this right here. And when I move everything over to set it equal to 0, I get this. Factor it, I get this. Check each factor. Well, if I plug a 0 in to the original, I'm going to have 8 times 0 is 0. So the square root of 4 is 2. 2 minus 2 does equal 0. So that checks. 4, if I plug it in, that's 32 plus 4 is 36. Square root of 36 is 6. 6 minus 2 does equal 4. So both of these check just fine. Okay. I'm not going to work this problem here. It's basically the same idea. With higher indexes, all you have to do is raise it to a higher power. Okay. So if I want to get rid of the cube root on this particular problem, then what do? I raise it to the third power after I isolate it. So I'll go ahead and subtract 6. That gave me negative 2. I'll cube both sides. Cubing the left side extracts the radicand. And negative 2 cubed gives me a negative 8. And then I solve it like any other equation. Subtract 3 and divide by 8. No worry with a cube root about an extraneous solution because you can have negatives. This one I'm not going to do, but you just simply add 5 to both sides, giving me a 2, and then raise both to the fourth power and then solve it. Solving 2 radicands is really even simpler because you can see in this one, if I square both sides, then the radicals both just completely disappear, leaving me the radicands. But notice on this one, when I solve it, I get z is equal to a negative 1. Well, if I substitute negative 1 in here, I have 10 times a negative 1, which is negative 10, plus 9. That's asking me for the square root of a negative 1. And again, there is no real solution to this. We're not going to get into imaginary with these. So even though you get an answer, doesn't mean that it's a real solution. Okay. In this particular problem here, you solve it, it checks out just fine. I won't do this last one, but just remember that when you square the left side, you're also going to be squaring the 3. So the left side of this would be 9 times 4t plus 5 is equal to 6t plus 57. And then at that point, you distribute the 9 and you solve the equation. Word problems, using some exponents, a couple things to consider. So in this particular problem with growth of bacteria, they want to, the T is the time in hours, and P is a function of T is the population of bacteria. And so how long will it take? So they're asking us to solve for T for the population to reach 800 bacteria. Well, that will be the P of T, the population at some time. So what do? I replace P of T with 800, and I go ahead and I solve for T. Well, I want to isolate the T, so I'll divide both sides by 100. And then the little trick that you want to employ is remember the power rule, that if you take a power and raise it to a power, then you multiply. So if I want to get rid of a rational exponent, then I can raise it to its reciprocal, because anything times its reciprocal is a 1. So that would eliminate everything here and leave me a t, because it'd be t to the first. So if I multiply the right side by the reciprocal exponent, I'm going to have to do the left side by the reciprocal. So this isolates the t right here on the right side. The left side is 8 raised to the 2/3, which is the cube root of 8 squared. Well, the cube root of 8 is 2. 2 squared is 4. So there's a solution. So if I want to get rid of an exponent, raise it to its reciprocal, but just do it to both sides. The last problem is going to be a little bit simpler, because they're asking you to compute, in this case, the body's surface area, which is A, given the weight of 27 kilograms. So this one, you just plug in the values, and we're just solving it for A. Okay, so this is just really a calculator drill. 27 to the 2/3, you could plug that into your calculator, get the answer, or you can think of it as the cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. So this is just 0.1 times 9, which gives an answer of 0.9 meters squared. Okay, so you can see this is not very difficult to solve these types of equations.